Happy Thursday, everyone. My name is Janane Suresh, and I thank you for joining my talk on deployment aware SBOMs. Let me start off with some context. When a baby is born in this world, we create a birth certificate, isn't it? It proves the baby's identity, but it does not tell us where that baby lives today. Software has a similar problem. A static SBOM is called the software's birth certificate. It tells us what was created, but during an incident, identity is not just enough. We need the location, owner, and exposure. Today, I will show you how to turn an SBOM from a document into a live defense map. This is the story of Appy, a software package. Appy is born in a build, it gets a record, and then it travels from source to build to test and production. The problem is that most of the records stay in the factory while Appy keeps moving. If a critical vulnerability hits today, can we find every place where Appy lives? That's the mission we are trying to solve from this story. Entering into the first chapter of a story with an introduction to SBOM, Software Bill of Materials. Similar to how a candy bar has an ingredient list, software also has a list of ingredients which is called the SBOM. It says which components, versions, suppliers, licenses, or even dependencies are inside the package. The modern software is assembled. It's not written entirely from scratch. So we use third-party libraries, frameworks, containers, plugins, and a lot of internal components that come with it. Without an SBOM, we are only guessing what could be inside the box. But with an SBOM, we already have a starting inventory. The next chapter of our story is to understand static SBOMs. Static SBOMs are the foundation or the birth certificate of a software, in this case, Appy's birth certificate. It lets us know what is shipped, matches known vulnerabilities, and also answers customer questions with evidence. So a birth certificate partially satisfies our requirement of finding where Appy exists. It only solves the identity problem, but the real issue starts when Appy leaves the factory. The next chapter explains the real problem. Appy does not stay where it was born. It moves. It moves through build, staging, production, and customer environments, even clusters and pods, even in modern cloud infrastructure. But the static record stays still. Software keeps moving. How do we keep track of this? When an exploitation starts, we need to ask ourselves this question. Did we ever build this component? If the answer is yes, follow-on questions would be, where is it running? Who owns it? Is it exposed? And what do we fix first? When everything is just a finding, everything looks urgent. But we are missing the context that would turn findings into actionable decisions. Since Appy keeps moving, we need to identify which of the following SBOM chapters can track the location. CISA organization describes 6 different SBOM types. Think of them as chapters starting from the design phase all the way till runtime. Design is the plan, source is the code, and build is the package, analyzed is the inspection for artifacts. All these put together gives a static document, or what we call static SBOMs. But beyond that, we have dynamic SBOMs. This is what happens when software moves outside the build environment. Deployed SBOMs and runtime SBOMs give different information. Deployed tells you where the software lives, and runtime SBOM gives you what is the software doing right now, what is active. SBOMs can be produced at any stage, but deployed and runtime views help during live defense. Now with this information, I was thinking about the theme of Secure Chain Conference, which also aligned with my topic about defending post-deployment. I'm going to frame deployed SBOMs with a simple loop. I would call it SRA, sense, reason, and act. Sense means to collect SBOMs, deployment telemetry, vulnerability data, and the VEX information. Now, VEX is the Vulnerability Exploitability Exchange, That indicates whether a product is affected by a known vulnerability or not. Once we have that information, the next step is to reason it out. That means to correlate the data into blast radius, identify the reachability and the ownership. Once we have that, the final step is to act on it. That means patch, communicate, and verify that the fixed version actually reached the running environment. This way, we are able to make the SBOM data actionable in the post-deployment era. This is a little story within our API story. I would like to take you back to a cold December morning of the year 2021 when an active exploitation in Log4j component shook the entire security industry. Incident handlers were hustling to find where Log4j was shipped. Slack was noisy, customers were asking questions, leadership wanted to know if we were exposed. If you are one of the people who were hustling hard during the Log4j exploit, then you are about to appreciate what I'm about to say. When a critical exploit like this hits again, I propose a way to handle that situation better. I would say the first thing we should do is not email every team. Do not have fancy spreadsheets because it is a time killer. But we search the live deployment map. It is not about producing another CVE list altogether, but it is about answering the first incident question. Where is the component running right now? Now, how do we do that? Our API story takes a serious turn now because we are about to learn how a deployed SBOM connects the Log4j record to the running environment. It is not just that Log4j exists somewhere in the code, but it should explicitly state every record. In this example, you see checkout API as the service that Log4j is running in. We have the production environment. It even tells the location to the specificity of which pod Log4j runs in. It is in the payments platform, and we also know that it is public and reachable. This is valid information. This is why deployed SBOMs matter to security organizations. They shorten the distance between finding a vulnerability and knowing who must act on it. Think of it like an operational join between SBOM data and deployment data. The search from the deployed live map returns 4 places of interest. Imagine if all we had was a static SBOM, we might treat these 4 as equal emergencies. But deployed SBOMs gives a context which changes the whole conversation. If you look at the graph, from top left, we have the checkout API, which is a fix first issue available in the production environment, publicly reachable. That would be the P0. And priority wise, number 2, invoice worker is also in production, but it is only internal. So I would place it number 2. Number 3 is where admin legacy component is behind a VPN with compensating controls in place. So it is not a fire drill at all. And number 4 comes a location where it is only in the dev environment and it is not even exposed. So to organization, this will tell us the different urgency, same component, but different urgency. That is how we move from a vulnerability management as a list to vulnerability management as a decision. It shows a different business risk in this situation. Now, the deployment map can be made actionable in 3 different moves. How do we do that? We start with patch. Patching goes to the right service owner. And then the next step comes in communicating it. It could also include the VEX information, whether the component is affected, not affected, or mitigated. And then the final step is to verify. The verification step confirms if the fix is actually running, not merely just merged to a repository. The value that we add is not in generating more data, but the value is that we reduce time taken to direction. The time taken to respond to an incident moves from days to minutes. This is where deployment SBOMs support continuous exposure understanding. It's not a one-time inventory. Imagine reporting to leadership with this action plan when a critical vulnerability hits your organization next time. Now, I recommend security organizations to do a small drill. You do not have to boil the entire ocean to do this drill. Start with one service that matters. It could be customer facing or regulated or even frequently asked about service during incidents. Just pick one. Generate or collect the static SBOM. Now you attach deployment context to it, right? Services, environment, owner, or any cluster information, pods, versions, anything that you can add to it. And then run this drill with a known vulnerable component. Take a look at the results. Do not measure success by how many SBOM files you have produced in this whole process, but measure it when your team is finally able to answer the question, where is the component running, within a matter of minutes. Now, I would like to leave you with some closing thoughts. Static SBOMs tell us what was born. Deployed SBOMs tell us where it lives right now. The security organization needs both. They go hand in hand. In the age of AI, the vulnerability window keeps shrinking and shrinking. Security organizations that can sense, react, and act across what is actually deployed defend better and faster. Knowing what you ship is good, but knowing where it lives is how you defend it. I hope this was an informative session for you. Thank you so much for listening.